In this video, we're going to be looking at inverse functions. Now, here's a simple example. Fx equals 3x is a function. Now, what does that mean? Well, we take the input x and we multiply it by 3. That's what this function does. Well, the inverse function is the opposite of that. Well, the opposite of multiplying by 3 is obviously dividing by 3. So in this case, the inverse function, which we denote by f to the minus 1 of x, is the opposite of multiplying by 3, which is dividing by 3. And in more mathematical sense, if fx equals y, then the inverse function is the function such that x is equal to f to the minus 1 of y. That's sort of the mathematical explanation for what an inverse function means. And that actually means that if you have a function fx and you apply the inverse function to fx, you just get back to where you started. So if you apply f to x and then apply the inverse function, you just end up at x. So that's the mathematical sort of idea, and we'll have a look at a couple of examples and this should become a little bit clearer. So let's have a look at a more difficult example. So here's our function fx equals 3x plus 2. Now, in order to find the inverse function, there's a standard method that we can follow. What we do is first of all we write down x equals fy. So we're going to write this down as our method to follow. Don't know why my pen stopped working. Okay, so we're just going to write x equals fy. So what does that mean? X equals, what's fy? It's 3y plus 2. Okay, that's our first step. Then our second step is to make y the subject. So we had x equals 3y plus 2, so that means x minus 2 equals 3y, so x minus 2 over 3 equals y. We've made y the subject. And actually, this is now our inverse function. What we worked out as y is the inverse function. So f to the minus 1 x is x minus 2 over 3. And that's the method we're going to use. We can check that this is true. Let's, for example, let's work out f7. F of 7 is 3 lots of 7 plus 2, which is 21 plus 2 equals 23. Now, if we've done it right, our f to the minus 1 of 23 should get us back to 7. So let's check. F to the minus 1 of 23 is 23 minus 2 over 3, which is 21 over 3, which is 7. So it did work out fine. Let's do another example. So again, we can use the same steps. Our new example is going to be, let's say fx equals x plus 1 over 5, take away 3. So now, same method, we're going to write x equals fy. So we're going to write x equals, f of y is y plus 1 over 5, take away 3. Now we've got to make y the subject of this. So first of all, we're going to move the 3 to the other side. We get x plus 3 equals y plus 1 over 5. Get rid of the divide by 5 by multiplying both sides by 5. We get 5x plus 3 equals y plus 1. Take 1 away from both sides. 5x plus 3 minus 1 equals y. multiply out the brackets and simplify, we get 5x plus 15 minus 1, so 5x plus 14 equals y. And there we go. We've now got what y is equal to, we've made y the subject, and now this is just our f to the minus 1. So f to the minus 1, x equals 5x plus 14. And again, we can check this by trying an input for fx and seeing if the f to the minus 1 gets us back to the start. So let's try f of 9. Well, f of 9 is just 9 plus 1 over 5 minus 3. That's 10 over 5 minus 3 equals 2 minus 3 is minus 1. Okay, now how about f to the minus 1 of minus 1? If I put minus 1 into f to the minus 1, I get 5 times minus 1 plus 14 equals minus 5 plus 14 equals 9, which is indeed what we started with. So if I apply f and then apply f to the minus 1, I should get back to where I started. That worked out in this example, so we have indeed correctly found the inverse function.